right. Let me double check, turn down the monitor. Glasses. Gain is good. Let me turn that down a little. Oh, great. Now I have feedback. 4 p.m. 4:02. All right, guys. So let's get started here. Well, let me switch that back. Let me know how I sound. I'm hearing feedback in my headphones, but I don't know if it's affecting you guys out there. So I'll just turn that down. Okay, so what I want to cover today, we're going about an hour early. I just wanted to give it a shot, see if it works out any better. Let me know what you think. Today I kind of had to do it, but maybe I'll continue 4 o'clock in the future. It just kind of depends on audience demand. Loud and clear. Awesome. Thanks so much. Okay. So today, right, this is the question I get all the time. We're going to talk about composite position, right? And I know I've gotten comments from some of you. It seems like everybody's thrilled with the metric. And I've got comments that like, wow, your values are wacky, and I kind of know, I don't dimension tolerances or tolerances in metric, so I don't have a good feel for what like the standard tolerance value should be. For the purposes of these demonstrations, I just pick round numbers. So instead of I could have written 0.0 leading 0. Something like this, which maybe it'd be more realistic. But I found when you're trying to learn something, you don't want to be sorting through decimal places. You know what I mean? And I kind of have that issue with certain GD&T textbooks. Although they're very good, you often see, something like this, right? And you get like a position, diameter, tolerance zone, some odd number, and you're kind of sorting through what all of this means instead of just simplifying it. And if you watch my videos, almost everything is the same thing. And I do that for a reason, right? That's so you're not thinking about what decimal places you're having to deal with, right? It just kind of flows. Oh, plus this is way easier to make a chart, right? If you see my videos, you've seen me make the the size or the bonus tolerance chart basically, and plus or minus, you have less spots, right? It's just quicker to make that chart. Okay, 10 p.m. in Europe. That sounds about right. Yeah, I'd really like to do something in the morning for Europe and India. So eventually, I know I've said this a couple times, I want to do Friday, like 8 o'clock in the morning, Eastern Standard Time, which would be more, afternoon for Europe and India. So I'll get there eventually. Oh, Brazil. Okay. Yeah. And hi, Gaia. We're on Brazil. I think it's Eastern time zone, right? Seems like it would be. It's got to be pretty close. Okay. So, enough about all of this. Let's discuss our composite position, and some people say composite as well. So for my viewers that might use English as a second language, I don't even know the correct way to pronounce it, composite or composite. Either one seems to work just fine. Maybe some English teacher will correct you, but I tend to say a composite. Okay. So let's talk about the difference here, right? Well, first, the difference here. If you have two symbols, that is in the ASME system very cleverly called two single segment. If you have a single symbol, that denotes that it's a composite. Composite. Oh, geez. No, I can't even remember how to pronounce it. In ISO, they're the same thing. So in ISO, it doesn't matter. As far as I know, you might correct me if there's an ISO expert in the chat. But as far as I know, in ISO, it's just housekeeping. Like, it doesn't matter. One symbol, two symbols means the same thing. So yeah, hi everybody in the chat. I'm seeing you pop in there. If you have a question, feel free to put it in there, and I'll try to answer it as quick as I can. Okay, so two single segment, has these two symbols. Composite has a single segment, single symbol. Composite is usually two segments, but it can be three. That is possible, and there's some examples of that in Y14.5, although I think they're fairly rare out there in the wild. But they are valid. If you need it, you need it. So I'll try to discuss two single segment eventually. I think it's a little bit easier to figure out than a composite. Now, as far as the definitions, the top. The top is known as the Pattern Locating Tolerance Zone Framework. So PLTZF, right? An easy 5-letter acronym. The bottom one is known as the Feature Relating Tolerance Zone Framework. Y14.5, I forgot about 2018. I know 2009. They actually suggest like how to pronounce these acronyms, which is really strange. I can't recall ever hearing anybody refer to it as the Plutz or the Fritz. Maybe that does happen. Mostly I just hear people say top or bottom, top of the composite or bottom. I think is a little bit easier than trying to say Platts or Fritz or Pattern Locating Tolerance Zone Framework. Most of the time it's two segments. Most of the time you could say the top segment, bottom segment. People are going to know what you mean. As long as you specify that it's composite and not two single segment. So just letting you know, this is on the senior exam, if I can recall. There's at least one question on this. For whatever reason, they're really big on these acronyms. And I want to say the question is specifically about the acronym. It'll point to the top and be like, hey, what's this called? And it'll, have a couple different versions of this. Okay, so what's the point, right? What do they do? Well, the top one is going to control translation and rotation to the specified datum reference frame. And that way is no different from any other position, right? It really is the same. If you're verifying this, you can ignore the bottom part to verify the top part. The bottom part is where it's a little bit different. Okay, so the bottom one is going to control rotation and the basic dimensions within the pattern. And I think Y14.5 does a bad job of getting that part across. It's not going to control translation to the datums, and I'll show you what I mean by that in a minute. And it depends how it's set up, but if it's a three plane system, A, B, and C, in this case it doesn't make a difference. It would make a difference if datum B is called out. Now I'll show you, I've got an example for you. I'll show you what that means, but that's really important to remember. No translation to datums for that second segment, or the Fritz. And yeah, Stock John, you're right. ISO doesn't use the composite segment. Okay. So let me set up this example. The example I like to give, I'm pretty sure I didn't make this up. I don't think this is just me that uses this. So I've got a box of outlet covers. You know, these are, being a homeowner, for whatever reason, I collect a bunch of these. So what I'm looking for is just this standard outlet to kind of explain this concept, right? So if you imagine this granite plate is a wall, right? So we put our outlet cover on the wall, we drill 2 holes. Those 2 holes have to be the correct distance apart, or else the outlet cover won't fit, right? So we've got to measure the outlet cover from somewhere. Say down here is our floor, right? Over here is a door jamb or something, and the granite plate is obviously our wall. What we're going to do at GD&T is basically say that as long as the outlet cover, these 2 holes are the right distance apart, it can be here or up here or over here or down here, right? As long as those 2 holes are the correct distance apart. Now, we can refine things. We could say that it's okay even if it's twisted like this relative to our floor, right? As long as the 2 holes are the same distance apart. Or we could say, hey, no, it needs to be oriented to the floor. So almost like a cosmetic requirement. And I'll show you how to do that as well. And when we do 2 single segment, we can specify it so that there's a tighter tolerance up and down than left and right, which could make sense for something like a light switch cover, right? We could tell, that contractors aren't using GD&T drawings, but notionally we could tell somebody, hey, it's okay if it's over here or over here, but the height difference is more tightly controlled, and these 2 holes have to be the right distance apart, and it needs to be oriented correctly to the floor. Okay. So let's set this up. So I'm going to treat the pad here as the wall. The bottom here, right, datum B is going to be our floor. Datum C doesn't matter as much for our purposes, but we'll say this is like a door jamb, right? Something to measure the left, right of our light switch. Now, if it's driving you nuts that I keep talking about light switch, imagine it's a bolt pattern for a pump housing on a big casting or something, right? Anything where you've got a pattern of holes that are related to each other more so than the surroundings, which can happen, especially on big stuff like a weldment or a big casting or something. Okay. So here's our 2 holes, and this is going to be definitely not to scale so that I can fit everything on here. So these holes are going to be 2 times a diameter of something. I actually don't really care. Yeah, well, we just use metric here. We'll say 2 millimeters. Oh, geez. Well, now I'm thinking. What is. Give me 1 second. 48. I guess I had to do a quick conversion to get. It was about 48 inches. The 1219 millimeters is 48 inches. I just rounded to 1200. So the height of a light switch above the floor is what I'm looking for here. And then this distance, let me again go to my little calculator here. I mean, you know, I guess in Europe there would be, right? Light switches are made in metric, so that the center distance, I don't even know what it would be. I just converted 3 inches, 76.2 millimeters. I don't know. I guess it's good enough, right? It's kind of like an arbitrary value for us. So this is our setup. What I'm trying to show here, and you know what? Let me just make this 75 millimeters. It'll make things easier in a minute. Okay. So let's say we did a calculation, and that's a whole nother video, the fixed fastener formula. And we found out that 2 millimeters is the largest position we can have for these 2 drilled holes for which the light switch cover will still fit over. Germans use DIN. Oh, I see what you mean. Yeah, in Germany you use DIN, not even ISO. I've heard that Germany just kind of does their own thing anyway. Okay. So I want to draw what that kind of looks like. So out of scale, say we've got 2 tolerance zones that are diameter of 2 millimeters each, and the distance between those tolerance zones is 75 millimeters. What we're saying here is that the axis of each, oh, that's not very visible, is it? There we go. The axis of each hole can be up to 75 plus 2 millimeters away from each other. So 75, here's 1 millimeter, and here's 1 millimeter, right? That's a total distance they can be apart. And I just bring that up because it's a good way to kind of think about what's going on. So we're saying that if those 2 holes are further than 77 millimeters away, our light switch cover will not fit over. And right, what I'm saying is these are at a fixed distance. If the holes in the wall are, say, here and here, they're too far apart, right? This light switch cover, it won't work. So the rub is, right, well, we could stick with this, but do we really need to control the height of this pattern to such a small tolerance, right? 2 millimeters. That's to make sure the cover fits over the thing. But functionally, does it really need to be controlled that tightly to the floor? When you go to flick a light switch, right, it's probably not that precise. It can be 10 or 20 millimeters or an inch or so off, and it'll work just fine. Now, aside from codes or whatever, and I know building codes that can be picky about this stuff, I'm just talking about functionally, would it work correctly if you were designing a building from scratch with no codes or anything. So if we leave it if we leave it like this, we need a very large precision instrument to measure from the floor, right? This is the most difficult thing to verify. We need a height gauge that's about a meter or 3 feet tall, or over a meter or 3 feet tall. And that could be expensive, right? Imagine you've got a casting for a I don't even cast those anymore. A weldment for a big locomotive engine, right? You don't want to have to precisely measure the location of everything if it isn't really important for it to be located in that way. So what we want to do is keep this relationship. I'll call this the feature to feature relationship, and kind of release this requirement, right? And this is going to be the requirement to Datum B. We want that to not matter as much. Now, back in the olden times, you could do this with a plus minus dimension. It's actually kind of neat. I think I made a video about it once. You could say, hey, this basic dimension, make this a plus minus dimension, and then still keep the GD&T. So the whole GD&T could float around your plus minus dimension. I don't know about ISO or DIN. It definitely can't do that in ASME anymore. That's out the window. It has to be a basic dimension. Okay. Now, just to really get this in here, let's say we use 10 millimeters for this position. Now that's going to make this easier, right, to verify this 1200. Now we don't need a precision instrument. We could literally use a tape measure, right, to verify that. That's a huge tolerance zone, 10 millimeters. And let me double check. 10 millimeters. That's about half of an inch, 0.39 inches. So that could conceivably be verified with a tape measure instead of an expensive height gauge, or putting it on a CMM and using up CMM time. Okay. So let me draw that here, and this is, let me draw it more to scale. So here's our 10 millimeter tolerance zone, again, not to scale. If we just went with that, now the axis of each hole could be 5 millimeters in the center. So essentially now we've got a center to center distance of 85 millimeters. We're saying that wouldn't work based on the function of this design. So what we're trying to do is have this kind of flexibility, right, to Datum B, the thing that's difficult to measure. And functionally, and no, I want to say unimportant. Functionally, this is what matters as well. I'm not saying it's just measuring stuff is hard. You want to get the design intent across, that the location of the light switch holes from the floor is less important than the holes to each other for the function of the light switch. Okay. So let's start with, give me 1 second. Okay. Oh, where am I? All right. So we've got 10 millimeters up here. The pattern locating area at the top. And 2 millimeters here. At the top, we have our same datum reference frame. In the bottom, I'm going to start off with no datum reference frame. Okay. Actually, let me move that a little bit closer. It's going to get a little bit tight here. So I'll put a little dividing line. So here's our notional tolerance zone, right? These are two 10 millimeter tolerance zones. They're whatever this distance is away, right? The 75. And then they're going to be whatever this is. The datum B. Okay. Now, that's all the same. Nothing interesting there. The bottom is where it's different. Now, the way I would encourage you to imagine this is you're going to have two 2 millimeter tolerance zone on a string. So imagine here's the center of my first tolerance zone. Here's the center of my second tolerance zone. This distance is going to be, that's the worst basic dimension ever, huh? It looks like a rock. Let me fix that. That looks terrible. There we go. Oh, I put the arrow in the wrong spot too. Okay, so imagine two tolerance zones are on a string. They're always 75 millimeters apart, but they're free to move around within those larger tolerance zones. There really is kind of an unlimited amount of movement as long as they keep that 75 millimeters distance from each other. Now, it's not that easy to verify, but it's not impossible either. But it has the function of, right, allowing this light switch to be up here, down here, over here. You know, it could be in all sorts of different spots as long as these two holes are the right distance from each other, right? Super kind of functional. Now, you often don't see a composite position with no datum references, and I'll show you why. Say we're going to look at this kind of the other way, right? Say this is the wall, and these are 10 millimeter tolerance zones, so we're kind of looking at it perpendicular to our screen here. Well, if these tolerance zones, these 2 millimeter tolerance zones, are not related to datum A, which would be the wall, the tolerance zones are free to be at any orientation as long as they're the right distance from each other. So for light switch cover, it doesn't matter because the the cover is so thin, you don't really need a projected tolerance zone or anything, right? It'd probably be fine. That being said, a 10 millimeter, you could have a very large, you could have a pretty big angle here, right? I don't know what it is off the top of my head, but it could impede, assembly. So that's why you don't often see, just this with nothing. So let's add our datum A. Here's another tidbit. With composite position and profile and ASME, you have to use the same datum references in the same order at the same material condition. So I couldn't put B. I can't do this. I can't say, oh, well, I want to use B here. It's got to be A, then B, then C. And these are all at regardless, these are all surface planes, so I can't have a material condition. But if it was a feature of size, then I've got to use it at the same material condition at the top and the bottom segments. Okay, so when I call out datum A, what's going to happen here is our tolerance zones, right, now need to be 90 degrees to datum A. And this is often good enough, right? It's similar to applying a perpendicularity. The difference here is that perpendicularity you can't use this basic dimension, right? So with perpendicularity, each hole is perpendicular to datum A, but they can float apart from each other within this big 10 millimeter tolerance zone. And you could conceivably override that with a note, but I wouldn't recommend it. It's just not going to jive with the ASME system. There are situations where maybe that's okay if it's a non-functional, I don't want to say non-functional, but say if it's, I don't know, ventilation holes or something where the distance between them doesn't matter all that much. And this, it does matter because, our contractor's going to be upset if all the holes are drilled wrong and light switch covers don't fit over. Okay. Now, what you've probably all been waiting for. What about datum B? Oh, jeez. At this point, let me back up. At this point, and I'm running real low on room. At this point, a composite and single segment in this situation mean the same thing. There is no difference. And I got into an argument with a colleague of mine about this, and I didn't really know. I just had a feeling that they were the same, but I went and looked it up one time, and I'm open to being wrong, but they're the same thing, right? It's interesting. In 1994, do I have it with me? Oh, no. If I could find my 1994 Y145, I think their description of composite position is much better. Give me 1 second. Everything except 1994. Got it. All right, let's take a look. So this is similar to the situation we're looking at now. I probably won't show the pages from 2009, but this is only in 1994. And I think it's a very instructive way of learning composite position. I think these figures absolutely rule, and I don't know why they got rid of them for 2009. Now, composite position didn't go away. I want to make that clear. Just that these specific figures don't exist in 2009 or 2018. And I just think they do a good job of breaking down exactly what's going on. Now, I'm not going to go through these in any detail because I'm doing that in the video, but it gives the 3 surface datum. It gives an example where you might have datums that are regardless of material boundary, which is actually kind of wild for ASME. Those of you that are like real deep in the game know that ASME hates using features of size regardless of feature size. Like they prefer everything be at MMB, and that's normally how you would see it. Well, I don't know. You definitely never see ASME call something out regardless feature size for the tolerance. But you often see that they like to use MMB for datum references. And I think just to show you that it's a thing. But in this case, they don't. So here's a couple other situations. And these are the same as, oh, here we go. Here's the MMB concept. Oh, and this is 2 single segment as well. These figures are the same as 2009. I'm telling you, if you learn it, if you're using GD&T on like a daily basis, 1994 is a good one to have. Like if your boss won't buy you a copy of the ASME standards for whatever reason, like, oh, I'll just use a textbook, or use it, look at the PDF or something. A print copy of 1994 is going to be your friend. I like highly recommend. If you can't afford the newer versions, which are like $250, cop one of these on eBay, like $40-$50. It's a really good way to learn it. Not that much has changed. Okay, sorry, a little sidetrack there. Being star, I get this question a good amount. Being star, I don't have Gear Pro for Calypso. Like I don't have it. If Zeiss wants to send me a copy, I'll happy to, go through the training, learn how to use it and stuff. And I just don't have it, so I really can't help. It must be a super popular product because I get this question in chat and email like all the time, but I just can't. I can't help. It's like asking me about piece of DMS. Like I just don't know. I'd help if I could. Oh, that's a good question. Match. So, I'm sorry. I'm not super familiar with Polish names. I'm gonna go with Matthews. Matthews. If there's a better way to, if you can, maybe I could type it in Google. I'll try to figure it out. But I'm gonna go with, how about just Matt for now? So Matt's saying, let's imagine there's a whole X and whole Y on one drawing. Can I control position of X with MMB and the position of Y with RMB? Okay. I think I see what you're saying. So you've got like a hole, and you're saying in the X direction you want to control it. Sorry, I know you guys need me to finish this composite position, but sometimes I get a question that's really intriguing, and this is one of them. So what I think you're saying is, hey, I want to control in the X direction, whatever, with MMB, and then the Y direction, and I could be totally misreading this. with just RMB. If that's the case, this is how you would do it. You would use two position feature control frames, and you're essentially creating, right, say they're the same value. Oh, that wouldn't have a diameter symbol. Say each of them is 2 millimeters, right? And there's no diameter symbol. So you're creating a square tolerance zone, but two basic dimensions. Oh, actually I meant hole number 1 named X and hole number 2 named Y. Oh, okay. Oh, 2 holes? Oh. Still a good question. Not as intriguing, though. Okay, so what you're talking about, you want to control one hole with regardless material boundary and the other with maximum material boundary. Does that create separate requirements? Sort of. I mean, notionally, that should create a separate requirement without a note because the inspection setup is different. Practically, if you want them to let me get to that at the end of the video if I can. It's not that easy of an answer. Okay, let me check something here. How many? 21. Okay, back to composite position. So yeah, these are the same composite 2 single segment when you only have one datum reference and you've got a 3 surface plane system. Now, if I add datum B here and add datum B down here, they're not the same, right? They mean something different. Now, what is that difference? What this does, and this goes back, datum B is going to control rotation, not translation. And that's really important to remember, to decipher these. You know, they're not always going to be this easy. Rotation, not translation. What in the world do I mean by rotation? Well, as we can see here, these 2 holes are crooked, right? Relative to, say, our floor here. What we want, and let me switch back over here. What we want is this light switch cover to be, you know, what do you call it? Perpendicular to the floor, right? We don't want it to be crooked. So when we invoke datum B, what we're saying is we want it to be perpendicular to the bottom edge there, datum B, but we're not controlling the translation. So it's free to move up and down, right? It's just an orientation control, just like we have going on here. Okay, so what would that look like on our drawing or on our sketch here? Definitely like this dark green, right? We're still going to have our 2 tolerance zones on a string, right? 75 millimeters apart. The way I like to think about it is that we'll strike a line through the center of each tolerance zone, right? And that's got to be 90 degrees to whatever datum B is. It's more difficult to think about, you know, I don't know. It's more difficult to think about the requirement than to just see it, you know, on the table here with this light switch cover, right? It's a practical thing. Just controlling the orientation, right? Just keeping it square, right? You might have seen that note, like older drawings, like, hey, you know, this needs to be created square and parallel, right? That's descriptive. This has some, you know, a little bit more meaning behind it, but that's essentially what it's doing. So we're not measuring. Datum B ignores this 1200 basic dimension, right? The tolerance, this is free to float within that 10 millimeter, that big tolerance zone. Okay, so what if, I definitely don't want to leave this out, right? What if it was 2 single segment? So I'll just recreate this down here. A, B, C. And we're going to go A, B down here. Now, with 2 single segment, now B does rotation and translation. So now we are locked in to this 1200 basic dimension to datum B. And what that has the effect of doing you end up with this almost slot-shaped tolerance zone in the middle of the part, right? Where this can only vary by 2 millimeters. Now it's given us a diameter, but I'll just call it out as that height, right? So those 2 holes, we're limiting the up and the down. And for something like this, like a light switch cover, where you might have a code inspector saying, hey, they've got to be within a certain distance of each other to the floor, this might make sense. The left and right matters less. One is not better than the other. Although, when I see any of these some of you may know, you can spot a drawing that's made really well, and you can spot a drawing that has issues. So if I see a drawing where I'm seeing little things like a datum. Here's a classic example. I'm sure some of you can relate. If you open up a drawing and you see datum feature symbols, like half of them are 3.5 inches long and half of them are too short, you're like, antennas up. Like, uh-oh, what else is wrong with this drawing? And then in the same drawing, when I see this or I see this, I question, okay, does the designer really know what they're doing? Do they really know the difference between composite and 2 single segment, or they just forget to click a button? Like, what's really going on here? So it can be tricky. They do mean 2 different things, though. Real quick on verification, I have like a whole nother video about this. What a lot of machine shops will do, and I don't blame them, is they're going to aim for this bottom number to this datum reference frame. Okay. So what that has the effect of doing, if you go to check this part, and both of the axes of the holes are within this little region relative to the true position, you're done, right? It's only when they're out here, right, that you need to consider those 2 tolerance zones on a string like I was talking about, which can be more difficult. Cool. Okay, we're at 51 minutes. That took a little longer than I thought, although I did go on some tangents here. I want to talk about this drawing real quick. I forgot to make it like publicly available, and I apologize for that. And I will use this more in the future. This is basically a hub and a what do you call it? Like a retainer or something. So the hub is this part right here, and the retainer is this part right here, right? So the hub fits. So we'll call this the hub, and it's going to fit in here. Now the tricky part, and I had a viewer, Matt, submitted his ideas for this. The weird part is that this hub is let me get it. Oh, this color is terrible. This hub is a taper. And that makes it difficult to identify that as a primary datum feature. I mean, you can, but it takes away 5 degrees of freedom when you probably don't necessarily want it to. The flats, right, you would probably pick, because the way this works, this side will go against this. And that could be probably your secondary datum, because you got two cylindrical things that fit within each other. You could make the argument that the pattern of holes, right, that should be, it wouldn't be the primary datum, should be the secondary datum. Yeah, it's basically a cone, which those of you CMM guys know can be kind of a nightmare to deal with. Oh, no, Reggie, I saw you had a question earlier. Let me see if I can get to it. Oh, that is a good question. Let me read that real quick. So, quick CMM question. If there's a square symbol, does that mean I create a center plane, or do I create a square and use the diameter tolerance zone? Oh, geez. Are you saying somebody put... If you're saying somebody put a square symbol in a position, well, any feature control frame, there's no support for that in ASME. It's not a thing, right? It makes sense, and I've thought about making a video about it. I think ASME would not want to do that because they want people to use the cylindrical tolerance zone. Although the square tolerance zone, right, you lose 57% of your tolerance or whatever. I think it's probably a good thing because it'd make more sense to people. But no, it's not permitted. If I saw this on a drawing, I wouldn't necessarily create a center plane. It depends what the feature is, I guess, but it's still going to be an axis. It's just now the axis needs to be within a square instead of the axis needing to be within a circle. The other situation where you can see the square symbol is, obviously you got like a square. If it has a basic dimension, oh, no. Right, this is legit. Oh, it could be a basic or a plus minus dimension. And that's just your basic dimensions, right? That shouldn't affect anything. It was a square. Oh, geez, it was a square. I'm assuming a square pen. Oh, a square pen with a diameter tolerance zone? All right, let's imagineer this. I'll get back to that drawing in a second, but this is okay. So we got a square pen. So I'm guessing, saying we've got a square symbol here. It was a square. What was the diameter? Was it tolerance straightness or something? Okay, so I'm going to guess it's straightness. Yeah, that's the only thing that I think would make sense. So we're saying, okay, we got like straightness. Okay. Okay, I've heard this argument before. Can you have, can straightness control a non-cylindrical thing? I think it could. I don't know if Calypso will calculate it that way. I can tell you the only examples in ASME are for cylinders. I'm pretty sure it says it's just for cylinders. I remember I looked into this one time. But logically, right, this is controlling the derived median line, which comes from derived median elements, which are just all the middles, right? So we check two spots on the outside, find the middle. As long as the shape has an even number of sides, like a square or an octagon, we can establish a derived median line from that feature. So as far as I know, It's not against the rules of nature, is what I'm saying, right? It may be against ASME's rules, but not against the rules of nature. Just a basic with a square symbol. Just a basic with a square symbol. Oh, if it's just a basic with a square symbol, oh. Yeah, that's just a all-around profile, right? I would assume that's how they're doing it. You just treat it. If you see a square symbol, it just means that, you know, this is 1 inch and the other side's 1 inch. Yeah. Square symbol is new for 2009. It wasn't a thing before then. So people are, I guess, just getting their feet wet with the symbol. Okay, back to this. Let me just go to our user submission here. For the TP, asking for the TP of the feature. TP, true position? Yeah, Reggie, you might have to send me like a little sketch of what you got going on there. I keep going down these rabbit holes trying to kind of imagine what you're telling me. Okay, so real quick, I'm running a little low on time here. Matt sent this in. Yeah, I like this. So he's calling out this diameter as datum A. So kind of avoiding this cone, right? And it makes sense because you've got a mating feature here, right? So this fits like a bushing that fits the basically the axle. So that makes total sense. I like that. And here's the thing with assemblies. It's not going to be perfect every time, right? In this part, it's only perfect when there's 2 parts that go together. In this case, there's more than 2. So you're not going to get datum to datum contact on everything, right? So we've made a decision, hey, datum A, this is a feature that's both functional and we can simulate, right? Whereas this cone is functional, right? It's going to fit in here, but it'd be a nightmare to simulate that, right? So we pick the one instead of the other, even though they do kind of the same thing. One is going to fit and kind of center, you know, an axle, or in this case, this round part. So I like that. Now, here, and I know the other version of this is using a surface and not a center plane. Here, this makes sense as far as the functionality of the part, right? We're saying one side of this, I don't even know what to call this thing, this hub, yeah, there we go, is not more important than the other. It's a symmetrical part. Yeah, they're 2 different parts, Brian. You had me for a second there. 2 different features of datum A. Yeah, they're 2 different parts. Yeah, so if it's like a casting or something, or forging, right, one side doesn't matter more than the other. And it doesn't matter more than the other in the function of the part. The tricky thing is it's going to be difficult to measure, right? Because you got to find the center plane and measure everything from it. So design intent wise, I sort of agree with it. So the other argument, do I have the other one? Oh, I guess I was drawing it. Nope. Okay. The other argument is to use a surface, right? In this case, the way this part works, you have something mounting on both surfaces, but you know, that's just going to happen, right? I wouldn't pick one necessarily over the other. This is going to be the easier to deal with at inspection because you can literally take this hub and to measure it, right, I could just put it on a V block, right, like this, right on this surface, and then take all my measurements from the top of this V block. It's going to be much easier than trying to make the measurements from the center. So, and then the other part I don't think anything changed on this. Yeah, this center, it's a good datum B, right? It's going to be the functional of the features, right? This OD, if you can see right here, just mates to air, right? We don't really want to make that a datum. Same thing here, right? This ID also mates to air, right? We don't want to make that a datum because we want to allow manufacturing to do whatever with that, right? That could have mistakes. Same thing with this surface, right? On the inside also mates to air. So Matt has chosen the one big surface that mates to something else, right? It's going to mate to the hub. And then B is the diameter, right, that actually kind of mates to something, right? It's going to mate to this cone. Now you could make the argument, why don't I make, the holes a datum feature? And you could. You could. I would have to think about that a little bit more as to whether that'd be a really good trade-off or not. But this setup is just fine. Okay, so we're at, I think, over an hour or close to an hour. Let me look. Is there a timer somewhere? Oh, an hour and 3. Yep. So I'm going to go ahead and wrap this up. Thank you, everybody, for sticking around. I thought I could cover all of composite position, but I guess I couldn't. So I'll have to save some for next time. As always, shoot me a DM if you have a question. I'll try to answer it on here. Send me a snippet of a drawing if you want me to cover it. If you send me a drawing, let me know if it's cool to show it or not cool to show it. And yeah, I will see you all next time. Thank you, everybody, and the regulars for showing up from around the world. So if you're up at 10 or 1 o'clock in the morning, thank you for sticking around, and I'll try to do some that are morning Eastern Standard Time and more reasonable times for Europe and India in the future.